All right, so we're gonna start doing some data analysis, but before we start doing some data analysis, reminder of what I talked about briefly yesterday in the morning. I know it was too overwhelming, right? But I just want us to remember what is the goal of what we're doing here. Because this is where we're going to start getting into some more details, gradually more details, right? And again, we're going to do this one step at a time, but still details. So what I want us all to keep in mind is that our goal is not to become experts in analyzing data from SMART, right? Our goal, our primary goal, is to feel comfortable with the approach. To look at this and say, oh yeah, I got it. This makes sense to me, right? And even if we're diving into more details, I want you to always ask yourselves, do I understand how to frame the scientific questions? And do I understand what cells are being compared? Does that make sense? All right, so here we go. What are we going to do in the next 50 minutes? We're going to learn how to analyze data from a SMART to address 3 types of primary aims. So we're going to start with the first 2 primary aims, comparing the 2 initial intervention options and comparing the 2 second stage options among non-responders. And then that's what we're going to do in the first part. And then we're going to do the second part, which is a preparation for the 3rd type of primary aim. And the 3rd type of primary aim was to compare embedded adaptive interventions. And what we're going to learn is how to estimate the mean outcome under just one of the embedded adaptive interventions. So far, so good? All of this I'm going to do in the context of the ADHD SMART study. Bill Pelham is the PI on this study. Where's Bill? He's not here. Okay, maybe it's good. I don't know. Is it good or bad? It's good if I make mistakes, All right. Let me say a little bit. I want to talk a little bit about the SMART study. But before I talk about the SMART study, a note about the code. Yeah, it's good that I put this slide so I don't forget. Nick will show you how to use SAS and R code to do these analysis. In this module, when I talk, you'll see that, I posted some, SAS code. It's just because I'm a SAS user, right? It was easier for me to explain to you how to do it in SAS. The reason I'm doing this, the reason you're going to see the code, is just because I wanted to make the connection between the models that we're using and the code that you use in SAS to fit the models, all right? But you can also do this in R. And I don't want to dwell on it. I'm just going to show you what it looks like. And then when Nick will take over, he'll guide you step by step through the process of actually conducting the analysis. Does that make sense in SAS and R? All right. Okay, so let's talk about the ADHD SMART study. By far, my favorite study. And the reason it's by far my favorite study is because it's the first SMART data I've ever seen and SMART data that I've ever analyzed. Right? So this was my first exposure with data from SMART. And I'm very grateful to Bill. I'm sorry he's not here to hear this. Actually, I told him multiple times. He's sick of it. I'm very grateful for having the opportunity to analyze, to get exposure to this data. It's actually pretty fascinating. So what is going on in this study? These are kids with ADHD, I think 6 to 12. And initially, they got randomized to either medication, low dose of medication, I think this is Ritalin, or low dose of BMOD, behavioral modification. This is a kind of a multi-component behavioral intervention, including components at the school, from the teacher, Saturday component to learn social skills, and parent training. All right. Response status was assessed monthly, starting at week 8. Every month, if the participant was classified as a non-responder, he or she got re-randomized to either augment or intensify. So augment means add the alternative intervention, the one that the kid did not receive initially. And intensify means enhance the intensity of the initial intervention the kid received. Does that make sense? Okay, so Shauna already told you how response status was assessed when she talked about an adaptive intervention. She gave you an example of an embedded adaptive intervention from this study. Right? So it was based on 2 measures, the individualized list of targeted behaviors and the impairment rating scale. All right, as long as the participant responded, he continued with the same initial intervention. So far, so good? Here's Bill. but he's on the phone. Okay. Sorry I put you on the spot. I'm showing you a study. It's kind of cool. All right. I want you to notice, though, that if you started with BMOD and you were re-randomized, you were non-responder, and you were re-randomized to augment, it means that medication was added to BMOD. If you started with medication, you were a non-responder, and you were re-randomized to augment, it means that they added behavioral intervention to the medication. If you started with BMOD and you were non-responder and re-randomized to intensify, it means that you received more BMOD sessions. And if you're a non-responder to medication and you were re-randomized to intensify, it means that you received additional medication dosage in the afternoon. Does that make sense? Okay, this is important because I'm going to ask you questions later. So what is happening here? There are two initial intervention options that are being compared. Medication, low dose of medication, low dose of BMOD. Slow me down if I'm going too fast, okay? Then non-response, response status was assessed monthly. It's kind of like a moving target. Do you see that? Kind of like in the extent study, where every month the kid can transition to the second stage because he can be classified as a non-responder. There are two second stage options that are being compared, augment versus intensify. And here comes the devil. So I have all kinds of bizarre cartoons on my slides, and the reason is that I have a teenager. My son is 14 years old, and he really likes to add cartoons to my slides. Sometimes it makes sense, sometimes it doesn't, right? So bear with me. Okay, here comes the devil. And the devil says, wait a second. What are you saying? You're comparing these two second stage options, augment and intensify. But these kids, they received different treatment from these kids, right? These non-responders, when you said they were augment, right? They received augment. Actually, you added medication, and here you added BMOD. And here you said intensify, but here you intensify the BMOD, and here you intensify the medication. Why are you considering them together? Do you see the question? Do you see what he's asking? Okay. The reason we consider them together is because we kind of look at this from a tactical perspective, right? From a service delivery perspective. From a service delivery perspective, the kids here and here receive the same tactic. The kids here received augment, add the alternative intervention, and here they also received augment, add the alternative intervention. Does that make sense? Same thing here. It's a tactic, intensify the initial intervention. Does that make sense? So here it makes sense to combine them, to think about these two cells as representing one single tactic. Do you see that? And now you're supposed to ask, what if it doesn't make sense? Yeah, right.
So I just want to clarify that the participants are randomized at week 8, re-randomized at week 8, but then they're not re-randomized every month, right?
So let me clarify, okay?
Sorry.
Starting at week 8, response status was assessed. As soon as they got classified as non-responders, they got re-randomized. So there are kids who got re-randomized at week 8. They were identified as non-responders at week 8, and they got re-randomized. But there are some kids who were responders at week 8, but then they were non-responders at month 3. Then they got re-randomized. That's why it's kind of like a moving target.
Can I follow up?
Mm-hmm.
So if they,
Sorry. So if they went into the, say, intensify med,
Yeah.
and they were still not responding, did they stay in the intensify med and they just intensified their meds again?
Yeah.
Okay.
I don't think so, but I think there was a protocol, and you can ask Bill about this.
Okay.
So intensify means like a protocol for intensifying the medication based on, whatever's going on with it.
okay, thank you.
Okay. There are 6 experimental cells coming out of this SMART study, right? 6. And the reason I want to emphasize this is, like I said, you're the next generation, not the next generation, and you're the next reviewers, right? Next generation is too big. One of the biggest misconceptions that people have when they see a SMART is that this relates to these experimental cells. They see 6 experimental cells and they're thinking, she wants to compare, individual cells, right? So she wants to do all pairwise comparisons of the cells. I don't. I don't want to do that. And the reason why I don't want to do this is because this SMART was not motivated by scientific questions relating to comparing individual cells. This SMART was motivated by two primary scientific questions. How to initiate treatment for these kids and what to do for non-responders. And I'm going to show you that to address these two questions, you need to compare chunks of cells, right? And not individual cells. I'll show you in a second. Then he started talking about this in his module yesterday. In this SMART, there are 4 embedded adaptive interventions. Now you already know what an embedded adaptive intervention is. That's the first one. Start with mitigation, continue for responders, and augment for non-responders. Participants in cells A and B are consistent with this embedded adaptive intervention, right? What you need to keep in mind is that an adaptive intervention specifies what to do for both responders and non-responders. If an adaptive intervention only specifies what to do for non-responders, we have a problem, right? Because, what are we going to do with responders? We're exposing ourselves to differences in terms of how people implement the decision rule. Do you see that? So that's why an adaptive intervention specifies what to do for both non-responders and responders. So both responders and non-responders are consistent with this embedded adaptive intervention, with this decision rule. Do you see my point? Yeah? All right, here's a second. Start with BMOD, continue for responders, and augment for non-responders. The third one, start with medication, continue for responders, intensify for non-responders. And last one, start with BMOD, continue for responders, intensify for non-responders. 4 embedded adaptive interventions. All right, we have sequential randomizations. And we talked about this yesterday. The sequential randomizations are not here to make our life miserable or difficult, right? The sequential randomizations are here to help us answer scientific questions about an adaptive intervention that we're trying to develop, right? So here, we don't know what to do initially. That's why we randomize. We don't know what to do subsequently for non-responders. That's why we re-randomize. Do you see that? Right? Okay. So the randomizations, what they do for us, right? They ensure that we have unbiased comparisons, right? That we can compare the first stage intervention options and the second stage among non-responders in a way that does not involve any alternative explanations, right? It's the virtue of randomizations, right? Do you see that? Okay, but also we do this in a way, the randomizations here, they're done in a way that ensures balance. And we talked about this yesterday. What do I mean by balance? Participants were randomized with equal probability, 0.5, right? So at the beginning, they had equal probability, equal chance of receiving either a medication or BMOD, right? And non-responders had equal probability of receiving either augment or intensify, right? So this means that for the first stage comparison, we're essentially comparing half of our sample versus the other half, right? Half of our sample received medication initially, and half received BMOD. For the second stage intervention options, we are comparing half of our non-responders, the half that received augment, and the half that received intensify. That's what we mean by balance, right? And this balance is preserved, Shauna showed you yesterday, even when you're comparing embedded adaptive interventions, right? Okay. Does that make sense so far? Okay, so this is what the data looks like. Let's go back for a second. So when I use O1 here, I use this notation to refer to any kind of information that was measured before the first stage randomization. A1 is an indicator for the first stage intervention options. I use O2 to describe any variables that were measured after the first stage intervention options were assigned and before the second stage randomization. I'm going to say it again, so don't worry about it. R is an indicator for the response status. A2 is an indicator for the second stage intervention options. And Y is the outcome. Okay, so this is what the data looks like. Note, this is fake data. Okay, it's not the real data. This is important. All right, ID, participant ID. Right? It's just an example of what the data would look like. And by the way, what the data that you're going to analyze, it's also fake data. ODD, oppositional defined behavior at baseline, 011, right? That's the variable, it's an indicator for ODD at baseline, taking values 1 or 0 for yes or no. 012, this is standardized baseline ADHD score. 013 is whether it's an indicator for whether or not the child received medication the previous school year. Race 1 and 0, white versus others. A1 is the indicator for first stage intervention options, coded -1 for medication, 1 for BMOD. Response status. R is an indicator for response status, taking values 1 for response and 0 for non-response. 012 is the time until the child got re-randomized, the time until the child was classified as a non-responder. Right? This could be an important covariate that we can use for second stage intervention options, but also a candidate moderator, right? Okay, I want you to notice something. So you see this dot, right? SAS users, right? Dot means missing value. This information, time until non-response, only exists for non-responders. You see that? If the child is non-responding, you have information about the time until non-response, but if the child is responding, you don't have that information, right? Does that make sense? In the same manner, look at this. For a responding child, you don't have information about A2, about the second stage intervention options. A2 is an indicator for second stage tactics, taking values 1 for intensify, -1 for augment. It's missing for responders. You see that? Okay, keep that in mind. This is important. School performance is our outcome. This is our primary outcome. It wasn't really the real primary outcome in the study, just for illustrative purposes. Taking the values 1 to 5, continuous, higher values are better. Okay, notice this. I use 01 to denote all these variables that were measured before first stage randomization. See that? And 02 to denote all these variables that were measured after first stage randomization and before second stage randomization. Do you see the order of things? Yes? Okay. Okay, so now that we understand what the data kind of looks like, now what we're going to do is we're going to learn how to use the data to address one of the primary aims that we discussed yesterday. This primary aim concerns the comparison between the two initial intervention options. Now remember, the first thing that we need to do is to learn how to frame these scientific questions. And there are various ways to frame it, right? So you can say that what you want to know is what is the best first-line treatment in terms of end-of-study school performance, controlling for future treatment by design. Or you can say that you want to know what is the effect of starting with BMOD compared to medication in terms of end-of-study school performance. Or you can say that you want to know, is it better on average to begin the treatment with BMOD or with medication in terms of end-of-study school performance. This is exactly the same thing, right? It means that you're interested in comparing the first stage intervention options, right? Averaging over the future, averaging over subsequent treatments for responders and non-responders. That's what it means. So far, so good? Okay, so how do we do this? Danny talked about this earlier, not later. How can you talk about something later? Anyway, this comes down, maybe you can, I don't know. This comes down to a comparison of all the participants who received medication initially and all the participants who received BMOD initially. It comes down to pooling outcome information from these 3 cells and comparing them to these 3 cells. That's all. That's all it is. It's a 2-arm comparison. Do you see that? Yes. Right? Okay, we're not comparing individual cells. Now, what I want you to keep in mind here is that, okay, the devil comes again. We are not ignoring second stage treatment here. We are not. This relates to your questions, right? About how do you frame it. We are controlling by design for second stage treatments, right? So think about it for a second. When you are just conducting an RCT, right? Say that you're comparing medication to BMOD, that's it. usually you're taking an intent to treat approach, right? So in intent to treat approach, you are comparing not the treatment that the person received, right? But the treatment that the person was assigned to, right? Right? You're taking everybody who were assigned to BMOD, you're comparing them to everybody who were assigned to medication, right? But things happen in the middle, right? Elaine, you talked about this. Things happen. The kid could, become a non-responder, stop taking the medication, the physician decided to do something about it, add more dose, reduce the dose, all kinds of things happen. But at the end of the day, you will still be comparing everybody who were assigned to BMOD and everybody who were assigned to medication, right? An intent to treat approach. Here, what's happening is that you are controlling for what is being done for responders and non-responders. You are controlling for this by design because you are identifying your non-responders and you're providing treatments to non-responders in a way that is more controlled. Do you see that? And this is why the way to talk about it is not to say, oh, I'm comparing the two initial options, ignoring what happened subsequently. No, you talk about it, you need to say it, sometimes very clearly to your reviewers, that you are comparing the two initial intervention options, controlling by design for second stage options for responders and non-responders. Does that make sense? Yeah. Okay. So now the angel and the devil are happy, and now what we need to do, yeah. Oh.
Controlling.
Oh.
The first two, but.
Oh, so you're comparing the first stage intervention options, controlling by design for second stage options for responders and non-responders. Okay, so how do we do that? How do we use standard software to compare the first stage intervention options? And by the way, it said in the previous slide that, this comparison is like, it's just a two-arm comparison and you can use a t-test. Of course, you want to be more sophisticated because we want to control for all kinds of covariates. But by the way, you can use whatever analysis that you're comfortable with. If you have repeated outcome measures, you can use growth curve models, multi-level models, whatever you want. For simplicity, we're just focusing here on end of study outcome, right? So how do we do this? First, let's talk about the coding scheme. A1, the first stage intervention options indicator, is coded 1 for BMOD and -1 for medication. Remember? Okay. So to compare the two first stage intervention options, what I can do is I can just take my outcome and I can regress it on this indicator for first stage intervention options. You see that? It's very simple. You see that I have an intercept and a coefficient for A1. Yeah? Everybody with me? But that's too simplistic, right? So I want to add control covariates. And here I add control covariates that were measured before the first stage randomization. That's really, really important. And C is for centered, right? We center the variables around the mean to make it easier to interpret the coefficients. Okay, so based on this model, how do I get the expected mean under BMOD and the expected mean under medication? Yeah.
Can you clarify again, how are you defining your covariates?
So,
It's the second way that you're...
it's this one. It's these. See? 011, 012, 013, 014, covariates that were measured before first stage intervention randomization. Okay. So, to get the expected outcome under BMOD and under MED, what do? We can do this based on the model, right? So, you take, instead of A1, you plug in 1 to get the expected outcome under BMOD. You see that? So just take this model. Instead of A1, just replace A1 with 1. Because, kids get 1, this indicator gets 1 if the child was assigned to BMOD. And that's what you get. You see the intercept plus the coefficient for A1 times 1. This linear combination of the regression parameters would give you the expected outcome under BMOD. Do you see that? You're familiar with that type of? Yeah? Okay. You do the same thing to get the overall mean or the expected outcome, the expected school performance under medication. Instead of A1 equals 1, right? Just use A1 equals minus 1. Just replace A1 with minus 1 to get the expected outcome under medication. You see that? Yeah? Okay. To get the difference between the two, just take this linear combination for the overall mean under BMOD minus this linear combination for the overall mean under med. This would give you the between group difference. The difference between starting with medication versus starting with BMOD. It's just, this is twice the coefficient for A1. Yeah? Very simple. Okay, so this is what this SAS code would look like. This is the model that we're trying to fit in order to be able to get the expected difference between starting with BMOD versus starting with medication. And to fit this model, we can ask SAS to use the GenMod procedure. It's a kind of a flexible procedure that allows you to fit linear models, but also generalized linear models. It's kind of flexible. You'll see when we get to comparing embedded adaptive interventions why we use it throughout. And you tell SAS, hello SAS, use this data. It's called DAT1. By the way, if this is interesting, my husband pointed it out, that when SAS works well for me, I treat it as a female, but when it doesn't, I call it like it's a he. I don't know why, but some of your psychologists, you can figure it out. Anyway, this is where we tell, dear SAS, please fit the following model. The outcome is Y, and take this outcome and regress it on the indicator for the first stage intervention options and my control covariates. That's all, right? You're just specifying your model here. And then you're telling SAS, hey, I want you to estimate, that's the statement estimate here, 1, 2, 3. 3 linear combinations of the regression parameters. The first one will be called mean Y under BMOD. This is just the name that you give this linear combination. And this linear combination would be the intercept times 1 plus the coefficient for A1 times 1. It looks familiar, right? Yeah? It looks familiar because that's what you're doing, right? Intercept times 1 plus the coefficient for A1 times 1 would give you the linear combination for the overall mean of the outcome under BMOD, right? Do you see that? Yeah? You're just specifying the linear combination of the regression parameters that would give you the expected mean under BMOD, the expected mean under MED, and the difference between them. Twice the coefficient for A1, right? Very simple. Just a note that, in case you were wondering, those of you who are not SAS users, when, you see, I'm not, in the estimate statement, we're not specifying the control covariates, right? Not specifying control covariance means that SAS will set them to 0. It will multiply them by 0. Right? So essentially, we're asking SAS to estimate the mean outcome under BMOD when all the covariates are at the mean, right? This is what I mean by making the interpretation of the coefficients easier. Do you see that? Does that make sense to everybody? Okay. All right. So this is what the results look like on the fake data. You see, this is the mean outcome under BMOD, school performance at the end of the school year. This is the mean outcome under MED. And that's the difference between them. So what would you conclude? Tell me. Here's your p-value. This is p-value, you see? Here's the confidence interval, right? So what would you conclude?
The other refute the null hypothesis.
Mm-hmm. Yeah? Yeah? So what would you conclude? So you cannot conclude anything because this is fake data. But if it wasn't fake data, you will conclude that starting with BMOD is slightly better than starting with medication, right? But the difference is not statistically significant, right? Okay, next. You can do this side analysis. This side analysis compares the 2 first stage intervention options in terms of their response rate. And a lot of people are interested in this side analysis, but there's a, what you need to keep in mind if you do it is that it's not useful in developing an adaptive intervention, right? And this is actually the first time the devil and the angel are going to agree. The reason it's not useful is because you're looking at the effect of the first stage intervention options, you're looking at the short-term effect before second stage options were introduced. So in a sense, some people call it myopic decision making, but some don't like this word. So what are you doing? You're actually making conclusions about the difference between the two initial intervention options, ignoring subsequent treatments. This is where you ignore the fact that the participants followed an adaptive intervention, that they received subsequent treatments, right? You're kind of like, you're comparing the two intervention options, BMOD versus MED, as standalone interventions and not as part of the sequence, right? Because response status was assessed before the entire sequence was introduced. Does that make sense what I'm saying? Okay, so, but you can still do this, and the way to do it is to use the proc-frec procedure in SAS. Just ask SAS to, provide a table of A1 by R, the response status, and this is what you're gonna get. This is interesting, you see. What do we see here? We see that for participants who receive medication, their response rate is higher than participants who receive BMOD. You see that? It's slightly higher. The difference is not significantly different from zero. The reason I'm showing you this is because many people like to do this analysis, but the bottom line is that it's not useful in developing an adaptive intervention. Do you see why? Yes? Okay. So let's talk about the second type of primary aim, to compare second stage treatments among non-responders. And this is a way to frame the scientific question. Your goal is to investigate whether among children who do not respond to either medication or BMOD, it is better to intensify or augment the initial treatment, regardless of the history of treatment, controlling for first stage intervention options by design. Yes? It's kind of like the main effect. When you were comparing the first stage intervention options, it's kind of like the main effect of the first stage intervention options, averaging over subsequent treatments. Here, it's kind of like the main effect of the second stage intervention options among non-responders, right? That's the way to think about it. And it's essentially, it comes down to comparing half of the non-responders who received augment in cells B and E, and half of the non-responders who received intensify in cells C and F. Again, it's just a two-arm comparison. That's all it is among non-responders. Okay, the devil's here again, but he has the same question, right? Again, why am I pulling outcome information from these two cells and from these two cells if they received, in fact, in practice, different treatments? We do this because it makes sense scientifically. It makes sense scientifically to think about cells B and E as representing the same tactic. And it makes sense to think about cells C and F as representing the same tactic, intensify. And by the way, if it doesn't make sense, don't pull. I'm serious, right? If it doesn't make sense scientifically, if you cannot justify it, then this means that that's not the right way to go about this primary aim. Does that make sense? Okay. So how do we do this? Kind of similar to what I showed you before, right? So A2, remember, is coded 1 for intensify, -1 for augment. To compare the two second stage intervention options, I can regress the outcome on A2, on the second stage intervention options indicator, right? Among non-responders. You with me? Okay. But I can fit a more, sophisticated model with control covariates. And notice that now you can add control covariates that were measured before the first stage intervention options, but also before the second stage intervention options were assigned. Right? So now I can include both my O1s and my O2s. Yes? You can always include covariates that were measured before the randomization, before the intervention options that you are comparing were assigned. Does that make sense? Okay, so again, how do we use this model to get the expected school performance under Intensify and BMOD and to compare them? We use the same logic that I showed you earlier. You see that? I'm simply replacing A2 with 1 to get the expected outcome under Intensify, and I'm replacing it with -1 to get the expected outcome under Augment. And the difference between this linear combination and this linear combination would give me the between group difference. The expected difference between non-responders who receive Intensify and non-responders who receive Augment. So far, so good? Look at the code. Now it looks familiar. Yeah? First, I'm asking SAS to restrict the data to only include my non-responders, because this scientific question is only about my non-responders. That's what I do here. And then, again, I ask SAS to use the GenMod procedure on the restricted data. I'm asking SAS to fit a model, take my outcome, regress it on the second stage intervention options indicator, and my nice, beautiful control covariates, and estimate 3 linear combinations of the regression parameters to give me the mean outcome under Intensify, under Augment, and the difference between them. Yeah? All right. So we understand the logic for the code. You can see, again, here that the estimate of between group differences, twice the coefficient of A2, is the between group difference. Yes? Yeah? Raise your hand if you're not with me. This is important because from here, things will get just a little bit more complicated. Just a little, just a little. So it's important that you stop me now if you're not there. Okay. And these are the results. And now I'm asking you, okay, wait a second. The mean outcome under Intensify, the mean outcome under Augment, the difference between them. These are the p-values, these are the confidence intervals. So, what can you conclude? You have to say nothing. You just have to. You have to say nothing. Yeah. So, if this was not a fake data, what you can conclude is that it is better to provide non-responders with the Augment tactic rather than the Intensify. And the difference is significantly different from 0. That's what you would conclude. And more specifically, you would conclude that on average, Augment is a better tactic for non-responders to either medication or BMOD in terms of school performance at the end of the school year. This is how you frame the results. Does that make sense? All right. Questions? Isn't this lovely? He has a very cool website. Yeah, I had to embarrass you, poor Nick. All right, questions before I hand it over to Nick? Am I on time? I'm on time?
You had so much extra time.
Awesome. Yeah. I have 10 minutes, Lisa? Yeah? Okay, great.
Further questions?
Yeah, questions.
I have, I guess, 2 questions. First, is there a reason why you use contrast code instead of the dummy coding, and what are the benefits of that?
I love this question. Shauna knows. So, I use contrast coding -1, because there are 2 reasons. First of all, it's kind of a tradition in factorial designs to use contrast coding, but also because I'm heavily influenced by John Ziak's work. Raise your hand, John Ziak. So John's been doing a lot of work in factorial designs, and what I learned, you can correct me if I'm wrong, what I learned is that when you use contrast coding, the Ender interactions between factors in a factorial design, the regression coefficients can still be interpreted as main effects and interaction effects, right? And this is why I keep using it. You know what I'm trying to say? Of course, now there are no interactions, so you can easily use contrast coding. What I learned from him is that there's no, it's not like right or wrong, right? You can still use dummy coding here, and you're going to be perfectly fine. Just watch how you interpret your coefficients, right? That's the thing that's going to change. right? Did I do it justice or not?
Another question I have is for testing, like the first name and the second name, I think in both cases, could we include for the first name, could we include the types of intervention people get at the subsequent stage as a covariate?
Yeah, this you can do.
Mhm.
Yeah. So when you're comparing the first stage intervention options, you can include the indicator for the second stage intervention options. You can. You're still going to be fine. And when you look at the effect of the second stage intervention options, you can still include in your model the indicator for the first stage intervention options, and you're still going to be fine. When you're not going to be fine is when you are controlling for covariates, because these are randomized treatments, right? If you would control for covariates that were measured, like if you conduct the analysis for the first stage intervention options, and you would control for information that was measured after first stage intervention options were assigned, this is when you're going to have bias. This is when you're going to have troubles. Yeah, Shauna is going to talk about these biases in the Q learning modules.
Thank you.
Yeah, more questions? Yeah.
So do you power that since they're both primary aims? Since they're both primary aims, do you power it at the aim 1 question or the aim 2?
Okay, this is very, very good, because it means I didn't do a good job explaining what we're doing here at the beginning, right? So the focus here was on showing you what would be the analysis if your primary aim was to compare the first stage intervention options, and showing you what the analysis would be if your primary aim was to compare the second stage intervention options, right? So, and of course, you can do these analysis, in a setting where you have both of them set up as primary questions, but then, when you size your trial, you need to take this into account, and also in the analysis in terms of the type 1 error rate. But we're always assuming that you have one primary research question that you have in mind when you design the study, right? And this is how you size it. And if that's the case, this is what your analysis would look like.
Right, so either one of them could have been
Your primary aim.
that
And
makes sense.
same thing, by the way, for the third primary aim about the comparison of embedded adaptive interventions. As soon as I switch to talking about this, you need to kind of put the, compare embedded adaptive intervention primary aim hat, in a sense, right? It's like, now you're assuming that the primary aim of the study is to compare two embedded adaptive interventions. Yeah? Okay. Other questions? Yeah. Sorry, you had questions here, or you're good?
I think it's not directly related to this study, but I think it has something to do with non-inferiority, testing the non-inferiority. In that case, do we use a single tail instead of, because it's a directional?
It's more complicated. It's more complicated than that, and I mean, like I said, if you want to, I can just have one module, like 80 minutes just talking about how to do non-inferiority and equivalence testing. It's more complicated than this. Actually, it's kind of like your H1 and H0, right, are flipped. And I can show you, I can talk to you later about this. I can show you how it works. Yes, more questions? None. Okay, so what we're going to do now, we're going to hand it over to Nick, who's going to go through the code with you.
All right, so I realize that I'm the only thing standing between you and lunch, but I have taught undergraduates at 8:30 in the morning on a Friday. So I'm going to try and keep this entertaining. Okay, so we'll start with SAS. So if y'all just kind of go ahead and open up SAS, our users will get to you in just a couple minutes. But we'll start with the SAS just so you can kind of see what the output looks like. So on your flash drive, you should have a folder at the top level called Code and Software. And if you open that up, you'll find a directory called SAS. Makes sense? Just open that up, and then if you're using SAS, you're on Windows. So you can just click this little bar up here, and it'll give you a file path that we're just going to copy here. So we can go into SAS now, and you would go to sort of open, and open up this file called SAS code modules 3, 4, and 6, ADHD.SAS. And if you need a second to find that, let me know. We good? Okay. So the first thing that you want to do before we start anything in SAS is we want to tell SAS where our data are. So the first line of actual code, all of this stuff with stars and in green is comments, so SAS doesn't run any of this. So here you'll see a libname statement and then libdat and then something in quotes that's probably like E:code and software or something, something, something. In between these quotes, I want you to highlight that E:something, something, something and just paste in the directory, that folder directory where the code and the data are. We all good? Okay, so we can run that, and then we can run this separate, or this second block of code here that starts with data ADHD dat, and to do this, we just highlight all of this code and hit this little running guy up in the corner, and this is going to load the data into SAS. If you're an SPSS user, you might be used to SPSS now showing you the data set in SAS, or in SPSS. SAS doesn't do that, it just sort of hides it, but it is there, and so to prove that it's there, we can run a proc print, which is just going to print here the first 10 observations of that data set. We can highlight, hit this little running guy again, and now, okay, so we have the first 10 observations of our data here. So we have an ID variable, we have all of these baseline covariates that Billy told us about, 011 through 014. We have our first stage treatment indicator, which is contrast coding, response, second stage covariates, second stage treatment, and our outcome. Okay, so now we can get some summary statistics. If you're a SAS user, this should be fairly simple. We're just going to look for some means of the data and get some frequency tables here. So we can highlight this, all of this proc means, proc sort, proc freq, and just run this again. And we can kind of explore the data just like we would any other data set, right? So here we can see that 49 people in the study were non-responders, and their they had early non-response, and then they were assigned subsequently A2 equals -1, which is augment. Here's A2 equals 1, which is intensify. So we can get sort of descriptive statistics in SAS. The next thing that we're going to do, and I know I'm running through this really fast, but it's because you've partially seen all of this, and because the majority of you are using R, actually. So in order to do our analyses, we're using, not only are we using contrast coding, we're also baseline, or mean centering all of our covariates. So this helps with interpretation of that intercept. So if we mean center all of the covariates, I don't have to worry about children having age 0 to interpret my intercept. I can say my intercept is the mean outcome for children at the mean age in my sample. So this proc means is going to tell us how, or what the mean is for every variable in our data set. So our data is ADHD dat, and we have this class R. So this is going to separate based on responders and non-responders. So we can run this, and now we can see we get this nice table where here are our non-responders, and here's the mean for each variable among non-responders. Here's the mean for each variable among responders. And we can use this information to now center our baseline covariates. So we're going to create a new data set that we call DAT1, based on ADHD DAT, which is the original data set that we read into the data, or read into SAS. And what we're doing here is we're creating new covariates. So 011C is a centered version of 011. So to create that, we're just saying 011C equals 011 minus the mean of 011 among all participants in the study. And then we end the line with a semicolon in SAS. We can do that for all of our covariates. And then we also mean center based on non-responders, because we're going to be doing some analyses that only look at non-responders. And so it makes a little more sense to center the non-responders just among non-responders. If we're only looking at non-responders, we only want to look at non-responders, right? So we're going to create another set of variables that end with C and R. So this is centered among non-responders, and we're just subtracting off that mean again. So we can highlight this code, we can highlight this code, run it, and we're good to go. And now we can make sure that it worked just by running a proc means. What should our mean be for every baseline covariate in this new dataset DAP1? What should we see when we get the mean? 0, bingo, okay. So we're just gonna take the means here to check and make sure, and then print the first 10 observations, right? So we can see our means, okay, this one's not 0, but it's pretty darn close, right? So they're all very close to 0. So that works, and now we have our new data set with a bunch of new variables, our centered variables, and our centered variables among non-responders. That was really fast. Does everybody kind of see what was going on there? Okay. All right, so now we get into the proc GenMod stuff. So this is what Billy has walked you through before. So we're interested now in looking at the main effect of initial treatment. So we're comparing all of the people who got med initially to all of the folks who got BMod initially. We're going to compare those groups. There are 3 subgroups in each, and this is averaging over subsequent treatment, right? So to do this, we're going to, we've got our model statement, y equals our indicator for first stage treatment, and we're going to adjust for our mean-centered baseline covariates. And now these estimate statements are exactly what we've seen before. So to get the mean y under BMod, we set the intercept equal to 1 and A1 equals 1. And this is going to give us the mean outcome among all of the the children who got BMod and have mean values of all of the other covariates, right? So we can run proc GenMod and our output looks something like this. So SAS is really nice in that it just sort of gives you a whole bunch of stuff. A lot of it is hard to figure out what it means, but it's all there, right? And so it's very pretty. So it tells us some information about the model that we ran, whether or not the model's a good fit, okay? And now it gives us parameter estimates for all of our regression parameters in that model. We've shown you a subset of this table in the slides. And then down here it gives us the results of this estimate statement. So, and again, we showed you a subset here, so we can see that the estimated mean outcome under BMod is 3.0459, with here's a confidence interval, here's some other stuff, right? And here's the p-value, okay? So again, remember that our conclusion here is in this last line, this between groups difference. It's positive, which means which one do we pick? What's among this? Well, okay, so our conclusion is nothing, right? But in this simulated data, what is the better first stage treatment? BMod, bingo. Is that difference statistically significant? No, perfect. Okay, so that was the first half of Billy's talk.
It's not perfect if you're trying to publish, right?
Right, I mean, well, I'm a statistician, Billy, I have to disagree. Morally, there's nothing wrong with a p-value that is large. Okay, so now we can look at second stage treatment options. So we're going to create a new data set here that just has a label for BMod or med, whether depending on, instead of dealing with ones and minus ones, here we just create a new variable that's BMod or med. And we can also just make the same comparison here using a t-test. So we can run proc t-test. For some reason, oops, I didn't run the data set. For some reason, proc t-test takes a really long time because it makes a bunch of graphs. SAS likes to give you a lot of things, right? Here is the same p-value we should have the same mean difference that we saw before, which should be, oh God. Right, okay, so we get the same means here, we get a similar mean, so we can do this using a t-test. Are we getting the same p-value, and are we getting the same estimate of the difference here? No, why not? We're not adjusting for any other baseline covariates. We're doing a different analysis here. In our regression, we could adjust for other covariates. In the t-test, we're just comparing these two means. So we're going to get something different. Okay, and again, SAS gives you a whole bunch of stuff. Right. Now here, this is our analysis that doesn't mean a whole lot in terms of the construction of an adaptive intervention. Right, this is comparing the two arms based on their proximal outcome, so the response status here. So again, we can just do this using a chi-square test on a frequency table. So in SAS that looks like proc-freq, right? And we're doing a cross-tabulation of A1 and R, and this is just saying I want some options. So don't give me too much SAS, that's what the no is. And this JISC thing says, give me a chi-squared test. So I want a chi-squared test and I don't want all of this other cruft. So we can run that. And the outcome that we're interested in, or the table that we showed you in the slides is right here. And the p-value for that chi-squared test is down here. Okay? Is there a significant difference, a statistically significant difference between the two treatments in terms of initial response? No. Great. Okay.
Yeah, I see it.
All right. You'll have a chance to kind of run this again. We're going to do some hands-on stuff. Okay, so in part B now, again, we're back to ProcGenMod. So now this is our regression to compare second stage treatment options, controlling for what's happened previously, right? So again, we're just going to, so remember that this analysis is only for non-responders. The responders were not given, or were not re-randomized in the second stage, so we're only interested in comparing the second line treatments for non-responders. So we're going to subset the data to get non-responders. And then again, this ProcGenMod that we've seen before. And again, sort of a similar output. It gives us a bunch of stuff. Some of it is interesting. Here are our parameter estimates that we've seen before. And then this is the larger estimate, or contrast estimate table. So this is where those values came from. Okay, that was really, yeah, thanks. That was really hot and heavy. How are we feeling? We ready to move on to R? Okay. Okay, so now, this is our studio. There is another folder on your flash drive called R. And that has all of the files for the R analysis. So if you're following along in R, if you have RStudio open, just go ahead and open that R file. So again, just open in the R folder. It's called R code modules 3, 4, and 6. So we can open that. And now the first thing that we're going to do with R is just tell R where all of our stuff is. We had to do that with SAS. In R, we have to do that as well. So if you're in RStudio, come up to this session dropdown, click that, and go to Set Working Directory, and choose to source file location. This is going to tell R that the files we want to use are in the same place as this code. So we'll set that. And now my RStudio might look a little different than yours. I have my code here and the console over here, so this is where all of the code gets run. Yours is probably below it, but this is easier to show folks. The beginning of this R script has a whole bunch of stuff that you don't have to worry about. It's just kind of maintenance things. And we define some functions that we're going to use later on. If you are like a hardcore R person and are really interested in code, you can go ahead and read those functions. I'm happy to talk to you about it. Otherwise, we're just building things that are going to let us imitate the estimate statements in ProcGenMod. So if you just highlight that code all the way down to line 79, and then click Run. It's going to probably install some packages, read some data in. It should take just a couple seconds. How are we doing? So just like SAS and R, we're going to read in some data. And R syntax looks a little different. So here now, in R, we're going to create an object called ADHD, and this is the data. So this says so ADHD is the name of the thing, and we're going to store whatever comes after this arrow as ADHD. So here we're going to use a function in R called read.csv, and we're going to give it as an argument the name of the file that we want, or that contains our data. So this is going to read this CSV file containing data into R and store it as a data set called ADHD. And if we run these next two lines, we can see that it works. So head ADHD asks R to print the first 6 lines of the data set that you give it. Why 6? They do not know. But you can change that, but it's 6 by default. So again, we can kind of see we've got the same data structure as before. And in R, our missing data value is NA instead of a dot in SAS. So anytime you see an NA, that means missing in R. And skip the next 2 lines, actually. So in R, it's also important, and in SAS, we were doing some sorting as well, but I sort of glazed over it here. We just need to sort the data by ID in order for some of this stuff to work. So we're just going to sort this and make sure that everybody is in the right order based on their ID number. And then we're going to print the first 10 rows of the data. So in R, R uses sort of a matrix notation. So here, the first argument in these brackets, this is rows. So this is rows 1 through 10. And then you leave a comma. And then whatever comes after here is which columns you want. So we want all of the commas, or the columns, sorry. Okay, and we can print the first 10 rows of the data here. We can see that it's sorted by ID. This next stuff is just mimicking exactly what we did in SAS. We're getting some summary statistics, and we're going to mean center the variables. In R, it's a bit easier. In R, we can create new variables by doing computation sort of standalone. So in SAS, we had to get the means, and then I had to type in 0.325, whatever. In R, we can just say, give me the mean of this thing. So this line says, in the ADHD data set, create a new variable called O11C. So the $ separates the data set from the variable name. And now, after the arrow here, this with says, use the ADHD data set. A comma separates that data set that you want to use, and now this is the computational part. So here I'm computing O11 minus the mean of O11, and I'm storing that as O11C. So this is how we're getting our mean-centered covariates here. So we can just highlight that, run all of that. And now if you look at the ADHD data set, so if we do head ADHD again, we can confirm that this worked, right? So now we have all of our data, O11C, O12C, so on and so forth. How we feel about this so far? This is not the fun stuff. Now we're doing the fun stuff. Okay? So now let's actually do this regression. So to do this regression, we're going to use a library that's called GEPAC. This is going to let us do statistics similar to what ProcGenMod does out of the box. So we installed this. That was when all of those progress bars showed up earlier on. So now to tell R that we want to use the functions inside this library, we just call library GEPAC. Okay, and now we're interested in comparing our first stage treatment options. We're interested in making this comparison between BMOD and MED as a first line treatment, averaging over subsequent treatments, right? This is the comparison that we're interested in. So to do that, we use a regression model, again, or like we've seen before. In R, that syntax looks a little different. So in R, we're using a function that's called GEE-GLM. So this says, do essentially ProcGenMod machinery. It's essentially the equivalent. But the model syntax is a little bit different here. In SAS, we specified a model by saying our outcome variable equals all of this other stuff. In R, that equal sign gets replaced by a tilde, and we have to separate all of our covariates by pluses. So our model in SAS was y equals A1 space, O1C space, so on and so forth. Here, this is how we specify the model. We also need to tell GEE-GLM what our ID variable is. We haven't seen this yet in SAS. ProcGenMod is capable of handling some of this stuff on its own. But we have to tell, GEE-GLM expects repeated measures, basically. So you have to tell it what a person means here. So our ID variable is ID. And now we give it our data set. So we say use ADHD data. And we're going to store this thing as something called model 1. So we can highlight this code, we can run it, and nothing happens. Or it looks like nothing happens, right? This model now is saved, though. And we can access this model by using this estimate function. This is a function that we built that is at the top of this R script. So when you ran the top of the R script, it loaded this estimate function in, and this is what gives us a functionality that's similar to the estimate statements in Product Gen Mod. So the first thing that we do with estimate is we call our model one, so that we tell it what model we want to get estimate statements for, and then we give it estimate statements. To do that, we use this R-bind thing. If you want to talk about why, we can talk about why. Essentially, we're just giving it a named matrix, if you're curious. But here, so ignore that. We just need this R-bind business. And so we're saying this is the name of this contrast that we're interested in. It's mean y under bmod, and this contrast corresponds to the following vector of regression coefficient, or regression variables. Remember in SAS, we did not have to say anything was 0. If it was 0, we left it out. R is not that smart. R needs a little more hand-holding. You have to explicitly tell it it's 0, right? Otherwise, it's going to get mad. It's scared. So we have a 1 for the intercept. Also, these arguments are positional. In SAS, what we could do is we could say intercept 1, A1, 1, everything else is 0. I could have said A1, 1, intercept 1, doesn't matter, I'll figure it out. R, you have to go in order. So the order of these values here corresponds to the order of the variables in the model. And an intercept is included automatically. So this first bit, this is the intercept. We say we want 1 for the intercept. To get the mean y under bmod, I want a 1 for A1, and I want the mean values of every other covariate, so I set the centered covariates equal to 0. Same thing for med, except A1 is -1. And now the same thing, I just subtract the second line from the first line, so that there's no intercept, and the difference here is 2. So this is the same thing that we've seen in these estimate statements, but again, we're just including the zeros here. So we can run this. And now this is our output that's very similar to what we've seen from SAS. So this estimate column is the estimate of the difference in means. We get a confidence interval here, a standard error, and a p-value. These numbers, if you compare them to the SAS output and the values in the slide, are identical to what we've seen from SAS. So we're using the same machinery, just in a different program. Okay? And now I'm being yanked. They don't have a cane, but this would be me being pulled off stage. So if over lunch you want to talk about the rest of the analyses in R, basically, and we'll see this afterwards, it's the same structure that it's just repeated over and over and over again. But if you want to talk about any of the specifics, when we have more time, please feel free. Thanks all.